Good morning, or it's just good afternoon. So, 1,000 miles viewers, welcoming you on a nice Sunday afternoon. Today, as we last week, if if you have been following us, we with Shibin we started this series of system design in AI era. Especially like if you have not watched the first episode, we will link it later within this. And just want to reiterate for the first time viewers, the whole idea was AI is developing software very fast, but what are the skills which are still very important and which is also lacking in many of the like upcoming students and the early software professionals who need to upskill in these areas to stay relevant in this AI era. So that's why we introduced this topic of system design. So system design is again very vast. We have lots of topics to cover. But last week we already told you that we will start with caching. We already gave a short introduction. We talked the high level about caching, and today the plan is we will go deeper into caching. Shibin, right? So the plan is we do it for around 30 minutes. We will introduce you step by step the concepts about caching and a little bit looking at different caching policy algorithms, policies used, and some standard system practices, design practices, which are very commonly followed. And we will definitely there are more to come after this. We will talk in the end what is coming later next. So, Shibin, yes, I think we can start the session today where we left off.
Yeah.
Maybe if you want to.
Yeah, let me share the screen. I prepared some content for the presentation.
Sure.
I mean, to continue from what Praveen has mentioned. So last time we have looked into why the caching is important, right? I mean, we have looked into where all it's currently being used. I mean, it's used everywhere. When we looked into like the browser caching was mentioned. Like, so last time we have how the browser is optimizing the caching, how the network bandwidth is being saved. So now for this session, we'll get into the basic principles, terminologies, and what you need to know. On a high level, I would say like caching is a very easy concept to understand, but very hard to implement. All right. So let's start defining some key terms. So any technology in software, right? You need to measure the efficacy of the things, right? Like you write a code, like if you have a database, like you have a various database technology, right? Like object oriented. I mean, RDBMS is there are like object storage. There are like uh, key value store, and like there are multiple ways to store the things, right? So for any of this technology, you need to measure the efficacy of the things. So for caching, the fundamental thing we measure is something called cache hit rate. Oh, sorry, cache hit rate, or simply hit rate. So what does this mean is total request or DB query, whatever the thing, I mean, whatever you are implementing with the cache, served from cache divided by total request or can you see? I think it's sorry. Oh man, how to minimize this? Okay.
Maybe you can push this around the whole color canvas itself.
Yeah.
No?
Just,
Okay. Yeah.
okay. Total request serve. So this is the basic thing we measure, right?
Yeah.
Why we need to measure is because there are multiple ways you can implement caching, like there are multiple patterns you can follow. So this basically tell us how good your system is working, right?
Yeah. Yes.
So why it's important? Think about you're designing something like similar to Instagram, right? So assume your cache rate is 90%, and you have a different algorithm. Like let's keep it in an abstract for now. We'll go ahead and explain the details later. But assume you have a different way which can provide you 99%. So what does it essentially means is the first approach, 1 by 10th of your query is served very fast, right? Like in millisecond, like couple of
Mm.
millisecond time. For the second approach, 1 by 100th request is served very fast. And mostly if you are using caching for the database read, assume there is a database read behind the scene, which you are trying to cache. This is like 10x less database load
Yeah.
plus 10x more uh, response time, right? So
Yes.
this techniques, which one to choose, when to choose is very important. 90 to 90% and maybe a break or make for your
Yes.
particular thing.
Yeah.
Okay.
So I think
So
just want to like give an example, little bit more like
mhm,
just think of Instagram, right? So in Instagram,
mhm,
if you're just
mhm,
like at a given point, I think probably 100 million people are using the app around the world.
mhm,
And
mhm,
if you, I think I mean, I saw somewhere like they have more than like maybe they are the 99% hit rate.
mhm,
And if they are 90%, that means they have 10x more load, right?
mhm,
So, which is huge considering millions of users requesting photos, videos, reels, etc. at the same time, and you're having 10x load means it's a huge cost and delay, like latency, lot of issues there. So that's the massive scale on which such apps operate. So you really have to ensure maybe like 99 or even better there. So yeah,
mhm,
I
mhm,
just want to give an
mhm.
example, Shivin. Yeah, you can continue.
Yeah, exactly, right? I mean, these numbers actually make or break your entire product. That is the importance of it. So this is the first thing you need to understand. This is what you have to measure. So whenever, I mean, assume some of you may be following it for interview preparation. So it's a usual question like, what is the expected hit rate based on your implementation, right? So now the second thing you have to understand is what is important. Like, what are all the, right? Like, you can't cache everything, right? Caching is like, I think the closest thing I can imagine, or like what is the closest analogy in my head is caching is kind of our bookshelf, right? Uh, I I love to buy like one book per month, right? So I've been buying for a couple of years now. So but my shelf capacity is limited. So I have a cardboard box where I keep the books. My shelf is nothing but the cache here. So whenever I buy new books, since my cache book, I mean, my bookshelf can only contain like 10 books at a time. Now I have to somehow manage it. Like I have to take the things out and move to my cardboard box. Sometime
Yes.
I may be like rereading some book. I may take something from cardboard box and move it back to the my shelf, right? So this need to be designed, right? There
Yeah.
are a couple of algorithms or couple of ways you can do it. That is that's a set of algorithm we'll discuss, and there is another aspect to the caching. That is all. I mean, we are caching the data, right? So data is not permanent. Like most of the data is not permanent. right? It changed. Say, for example, it's a profile information, my profile WhatsApp photo,
Yeah.
or like my Instagram WhatsApp photo, right? It changes. So you
Yes.
can't cache it for eternity, right? You
Yes.
need to evict it based on the time aspect. So that is the second aspect we'll discuss, right? So let's get started with the first one. That is like, what are the algorithm we can use to determine if your system is full, if your cache is full, what should be the algorithm to be used to select a item to be removed and replaced with a new one, right?
Yes.
So there are will I mean most of this computer science students, I mean, if you ever taken any course, this algorithm may be very familiar to use. I think. Okay. So let's start with the FIFO. Okay. FIFO is the simplest thing. So what it means is, whenever your cache is full, you remove the first one which entered, right? Say, for example, uh, going back to my bookshelf example, I have started collecting book. Assume I only have 12 place. I collect by like one book per month. Whenever I'm buying a new book on January, I just remove the last book I bought last year January, like the first one, right? Then replace it with this thing. Like February, whenever I'm buying, like the second in the line, the last year February, I will replace it. So basically, you maintain an order, then remove the first one which entered in the cache, then create a space for the new item. So that's it. Simple. Like FIFO. I mean, what I feel is like the FIFO is the uh, most used algorithm in human
Yes. Yes.
uh,
Yes.
life.
Yeah. Like
It truly
everywhere,
is a
right?
god.
Anywhere you go, it's like you expect basically first in, first out. So
Yeah, even in a restaurant.
restaurant, movie theater, like any queuing system, like you just
Mhm.
you go in first, you want to come out first.
Correct. So, uh, yeah, FIFO is the simplest one and most intuitive one. The second one is least recently used. So basically, what you do is like, uh, there may be a pattern at which you access it, right? Like,
Yeah.
so whenever you want to find a space, you remove the least recently used. I mean, the name itself tell entire algorithm. Uh, the last one is least frequently used. Like, say, for example, instead of uh, considering the last usage, you keep a counter of how many time it has been used, how
Yes.
many times it has been used, and least frequently used, you remove it.
Yeah.
So where it comes, right? Say, for example, let's go back to the Instagram example.
Yeah.
Instagram, I don't know whether they use LRU, LFU. It can't use FIFO. I mean, FIFO is not efficient for, say, they may be using all of it, but assume for the viewing, right?
Yeah.
It's better to use LRU or LFU because first in, first out doesn't make sense. If Cristiano posted a post,
Mhm.
right, a lot of people may be accessing it.
Yes.
So it
Exactly.
may be better to use uh, I mean, least frequently used out rather
Yes.
than using a blindly FIFO algorithm,
Yeah, just
right?
assuming like Cristiano Ronaldo is posting and a new person, like let's say me with like 10 followers, is posting,
Yeah,
it doesn't make sense to keep mine for a long time. And so, because Cristiano, millions of people watch in like in the first hour itself, right? So that
correct.
makes the whole sense. Yeah.
Yeah. So that is the like an abstract idea of this thing. These algorithms are also simple as it as we explained. You just have to conceptually understand it. Now I created an HTML page that may help you to. like play around. We won't spend much time. Let's spend a 1 minute on it. So what it has is like I'm going to insert all these entries, and this is the behavior for each of the things we have explained. One is FIFO, one is least recently used, one is least frequently used. Okay. So
Yeah.
let's see the first one. First one, you added A. There is already space. So there is nothing to evict, right? I mean, you already have space in your shelf.
Yes.
Okay. Now you add the B, you add the C, you already have space. There is no complication. All the algorithm looks same.
Yeah.
Now A comes again. Of course, it's available in the thing.
Yes.
In your cache, you serve in the cache. There is nothing to eviction, like because
It can be already
now
ready.
B,
Yeah, I
yeah,
want to
B.
just chip in. Just maybe you can talk about the what is changing, right? In each of the algorithm, the counters, or in LFU we have a counter, in LRU we have a used counter. So maybe you can just
Mhm.
say a little bit about that.
Yeah. In least, I mean, you can see here like used at 4. I mean, Praveen is you're talking about this thing, right?
Yes, yes, exactly.
Used at
Yeah.
5. So basically, as we mentioned, least recently used, you have to identify when was the last time it has been used.
Yes.
It could be a timestamp, anything. It could be anything, but you have to somehow identify, right? So that's what this number mean. I mean, just for the explanation, I kept it. Mostly people keep timestamp for it.
Yeah. Makes
Uh,
sense. Yeah.
and least uh, free, frequently used, I'm just keeping a counter. Say, for example, A has been, we are here, right?
Yeah.
A has been used twice, B has been used twice, C is already, I mean, only used once.
Mm.
So till now, all the algorithm is behaving same. The first time it was not there, so it added. The second time it hit, it served. So no change has been done. Now let's go to when it comes D, your cache is full,
Mm.
the
Yeah.
item is not in there. Now you have to replace. That's where this algorithm differ, right?
Yes.
In FIFO, what it did is it removed the first one it got added. That is nothing but A,
Yeah.
right? In LRU, it identified which was the least recently used, right?
Yeah.
So in that case, C is the one. Like after C, A and B is already
Already used
used,
one more time.
used
Yes.
one more time. So it evicted C. Here we evicted A. Here we evicted C. And in the frequency wise, if you see, again it's C because A and B has been requested twice. Now let's
Yes.
go to A comes. Again, you can see this counter vary, right?
Mm. Yeah.
Here timestamp 7th request it used. I mean, in practice, as I mentioned, it's a timestamp, but here we are like 7.
Seventh
You
item.
can
Yeah.
say
Eighth.
B come like all the entries are here already. In FIFO, again, there is an eviction call happened here, but I hope you guys understood. FIFO is the easiest one to understand.
Yeah.
It evicted the uh, now E comes, right? Both are behaving same. Do I have an example where LFU and LRU vary? Maybe. Oh, yeah. Oh, I think I created a wrong example. I should have
Okay. Okay.
created a better one. But I hope you guys, I mean, you see it's at the end, it is printing the hit rate. That's what we
Mm.
discussed, right? The 4 time in FIFO case, 4 time it found in the cache 12 out of 12 requests in LRU 6 and LFU
Mm.
6. I mean, it has been
50%.
identical, but yeah, based on the frequency, it could change, right?
Yes.
So this is a whole point, right?
Mm.
Um, so this, whether you pick FIFO, LRU, and LFU, change your entire application performance.
Yeah.
Mostly, I mean, most of the time, I have seen people pick LRU or LFU. But yeah, there is one more variation. Like, let me, I think I opened the Redis one. I mean,
Yeah.
Redis we'll talk
So
about.
you mean the policies? You want to go to the
Yeah.
Redis like different algorithms? Okay.
Yeah. So the Redis we'll talk more in depth in like maybe like a next session or next to next session. But assume it's a cache provider,
Mm.
right? Or it's a yeah, it's a cache provider, key value cache provider. So look at its policy, right? It's almost same except LRM. Like LRM, let's discuss when we discuss the Redis. But usually it only have LRU and LFU. Then an alarm. Alarm is like you can read here. I mean, it instead of uh, evicting LRU, I mean uh, least recently used, it it evict the least recently modified because you can
Mm.
modify the things. So we'll discuss more when it comes to the
Yeah.
Redis.
I think we can do that.
And
Yes.
and you can see there is an similar uh, policy with volatile added,
Mm.
right? So where it comes volatility or the time thing, right? It comes more about the expiration of the things.
Yeah. Yeah. This is a time to live concept we talked about.
Correct. Yeah, yeah. So basically, what I forgot the name of the person who said it. The hardest in software engineering, the hardest two problems are one is naming the variable, second is cache eviction. Okay, that is it.
Okay.
Uh, so, I mean, in LLM era, naming the things is not hard, but it used to be
Mm.
very hard. Like my all these PRs used to have like, can we name it like this? Can we name it like that? It to have like multiple iteration.
Mm.
So, other as he mentioned, I mean, as the author of that code clearly stated, caching eviction is a very hard problem, right?
Mm.
There are two things like it can impact. Like one is like data got replaced,
Mm.
right? Say for example, I changed my profile picture, right? The profile picture is most of the time it's stable. Most of the system cache it for like hours or maybe like if it's a company photo and all, they may even cache it for months
Mm.
because it's easy to manage like that, right? But assume I changed the thing, the data has drifted from the cache, right?
Yeah.
Now you need to replace the data, right? That's a very hard problem to detect, right? When it drifted from the source. Each of the time you can't like call and check it, right? That's equivalent of loading the DB.
Yeah.
Like if for each of the requests, and then you can directly retrieve from the actual source of truth and provide the result, right?
Mm. Yes.
So that part is there. So most of the time, what people does is a time-based system, right?
Mm.
So instead of not getting into this complexity, we say there is an expiry for this data,
Mm.
right? This website has an expiry of you can cache it for uh, 1 hour,
Mm.
or you can cache it for 2 hours, or like 1 month, right? Um, that is the default caching we provide. So after that, it tries to automatically like invalidate, assume a new request comes, the previously cached one is out of date, it tries to get from the source source
Okay.
of truth, right? So that is the easiest thing. So all these volatile things is we'll get into the details when we
For
discuss the
the
Redis,
Redis
but
session. Yeah, sure, sure.
yeah, correct. So uh, the one aspect I want to mention there is probably the um, how would I put it? I mean, in internet, like
Mm,
most of the providers, whenever you develop the website, right, by default has some sort of caching mechanism,
mm,
uh, like this is the how long you should cache it, like 30 minutes, 40 minutes. And most of the providers, like say, for example, any CDN providers, provide an explicit way whenever you deploy the website, right? So basically you call it say invalidate all this cache and you should start pushing. Like so usually most of these cache providers will have a control for you to call it and say like this entire data under this route has been invalidated. You should always fetch from the backend.
mm.
So that's how they control all this the new website deployment because website get updated all the time, right?
Yes, yes.
So that those are the basic concepts. Just to
Mm,
reiterate, we have defined what to measure, how you
mm,
can like whenever you uh, decide between either of the algorithm, what to be measured. Sometimes people run both the algorithm or like all the algorithms, or sometimes they pick like if they are in confusion with the least frequently used or least recently used, they may run both in parallel, A/B testing,
A/B testing. Yeah.
and
Okay.
find the hit rate and like decide it.
Mm,
They may simulate it. They might not even run it like based
yes.
on the numbers. They may simulate it and decide. And the second thing, the eviction, uh, when the data get invalidated.
Mm,
That is the other aspect, the time-based aspect,
yeah.
or the invalidation policies.
Mm.
We can get whenever we design the actual system, we can get into the depth.
Depth of it. Yeah.
Now, yeah, we have understood the core concept. Now there are like a couple of design patterns around it, like
Mm.
how industry actually use it,
Yeah. How
right?
in when you develop an application, what are the common designs followed,
Uh,
right? So that's like what how the cache is uh, interacting with your application in that sense.
Yeah,
Mm.
caching can be implemented anywhere, but the most strong implementation is around the database, I would say. So I have
Mm.
looked for some good resource. You
Yeah.
you don't have to read this thing. This is, I mean, if you are curious, this is a managed cache service by AWS. It's called DAX. Runs uh, runs in front of DynamoDB. If you can enable it,
Mm-hmm.
runs in front of DynamoDB. DynamoDB is a data storage by
Mm.
database by Amazon or AWS. So it has a good blog and image. So I didn't want to recreate the things. And probably we can link this also in the video.
Yeah, sure,
So
sure.
they
Yeah.
have mentioned design patterns, or like 5 patterns of usage. Let's go through each of it and try to understand, right?
Mm.
So the first one is what is side cache, right? What it means in practice is this is where the first of all RAID is a side cache.
Mm.
So
Okay.
what it means is your application logic is going to manage the cache, read and write, right?
Mm. Okay.
So basically, you add new entry to the cache, you read from cache. Um, I mean, you can have like you have already seen eviction policies
Eviction
by Redis.
policy.
You can have eviction policies in cache, like most of the providers support it. But basically, you manage it like
Mm.
cache. Like in the application code itself, you'll have a logic. Okay, I'll check the Redis cache, get the response. If it miss, get from database or the source of truth, and write to cache also. Then
Mm.
return the response.
So this
That's
is
going to be your
like, for example, like it could be some user profile loading once from DB and keep it in cache for quick access, like
Mhm.
product pages, blogs, like that, right? Some
Yeah,
application.
exactly.
So, but basically,
Correct.
it's in your control. Like you as an application decide how you handle the cache, when to.
Correct.
Okay.
Yeah. You may get some, like if you are working in cloud, you may get some hosted solution by that cloud platform.
Mm.
But so basically, it's your responsibility to manage it.
Mm-hmm.
But there is a other concept, right? Where the system manages the things. I mean, as I mentioned, DAX is a managed cache
Mm.
for DynamoDB. So what this means is you can see when these diagrams are numbered, right?
Mm-hmm.
So whenever there is a read, you never interact with the database,
Mm.
right?
Okay, got it.
You always read from the middleman, that is DAX.
Mm.
DAX decide whether the entry is there or it's cached, it's evicted, blah blah,
Mm.
all the things logic will be decided there. If it need to go and get from the DynamoDB, it will go and get it from the
Mm.
DynamoDB and just respond it back. So it's
Okay.
a managed way, like your application only interact with the DAX.
Mm. So I think
Okay.
thinking of it like maybe like a content CDN content delivery network, right? Like if you want to
Yeah.
pull some data, if it already it's cached, you just return it, or
Correct.
you just need it, it will stream from the DB and manage
Yeah.
everything for
CDN
you.
is a
Like
great.
it, yeah, you don't have to. You don't manage that part. You are basically offloading the DB reading part to the cache itself, cache management software itself.
Correct.
Nice. Okay.
Yeah. The CDN basically manage our entire website, right? Like
Mm.
it may get from the host or not. I mean, CDN is a great example. Thanks for quoting it.
Yeah.
Yeah. Then write through cache, it's same. The one we've discussed is the read pattern. This is
Mm.
more of a write pattern, right?
Mm.
So basically, write what it means. It's one, two, three, four. So this may looks very silly to you, but it makes a lot of difference in the latency. So
Yes.
what it means is whenever app request a write, DAX write on its own storage. Basically, it has its own cache, right? Behind the scene, it may be using some technology. Uh, and it writes the DynamoDB.
Mm.
After DynamoDB write only, it confirms the write is succeeded.
Mm. Okay.
So otherwise, it's considered as failed. So
Mm.
basically, it's a locking mechanism. You write both.
Mm.
If you don't write both, it's a failed state. Like so, what
So I
it
think,
implies is,
yeah, like a more
Mhm.
like a shopping scenario or even bank balances, things like that, right? If something
Yeah,
changes,
but
you write back to the DB so that it's valid in the next read.
mhm. Yeah. So bank balance is a great example. So where
Mm.
this write through cache is required is you want write to be persisted, like
Mm.
no matter what, right? So in bank balance, if somebody transferred a money, you have a cache sitting in between,
Mm.
you can't lose the data, right?
Yeah.
So whenever the write happens, you need a guarantee that it is persisted.
Persisted.
Assume
Yes.
the cache got restarted, the power got lost, you can't miss the data point. So
Yes.
it needs to be persisted.
Yeah.
So that's where this write through cache comes. Everything goes through it.
Mm.
Then the other pattern is, let's come back to the write around again. I think it's easy to understand write back first. So write back cache is it's simple. Whenever there is a write happens, DAX or like whatever the middle layer, like caching layer, doesn't write immediately.
Mm.
It keeps in its system. Like it depends on the implementation, but for your understanding, for a simple conceptual understanding, you can think it's like it wait for 5 minutes and group it together and write to the
Mm.
database. Or it
Okay.
may load balance it out, or it may do something like wait for 5 minutes or like till it has 100 entry and write it as a batch.
Mm.
Something, some
I think,
whatever it can do.
yeah, I mean, for example, we talked about the Instagram. So Cristiano posts a photo. There is
Mhm,
probably likes coming in hundreds and thousands in seconds. So probably you don't have
mhm,
to call DB for every new count, right? So you just wait,
mhm,
accumulate it every 5 minutes, then you write it.
mhm,
So it's better than
mhm.
just calling millions of times for the DB.
Correct.
So such
Yeah,
cases.
you can add the if the same record is getting updated multiple times, right?
Mm.
So you only have to write once also. That
Yeah.
is another benefit, like, as you
Yeah.
rightly pointed out.
Mm.
So what it essentially means is whenever assume there is a problem with the cache,
Mhm.
it got restarted or the like memory got corrupted or some or other thing happened, it's not 100% guaranteed the data is
Mm.
persisted in behind or parent system. I
Okay.
mean, we are talking about DynamoDB, like backend database storage here. It could be any source of truth. It could be some
Mm.
other API to be called. But uh, what it means is, like as you rightly mentioned, like the the star count or plus count or
Mm.
likes count,
Yeah.
exact number doesn't matter, right? Like
Yes. Yes.
you drop couple of count from like millions doesn't matter, like, but you can't drop $2. That's
Mm.
when you
That is
want right
more
to.
sensitive. Yeah. Agreed.
Yeah. And the difference here is write back cache is less. I mean, it's faster because you are not waiting for the item to be persisted for right?
Mm.
It's fast, so it's always a question of whether you want 100% persistence or better velocity. So
Yeah.
in software engineering, everything is a choice, right?
Yes.
Right around means it doesn't go through cache at all.
Mm.
Just so this pattern, I don't know, you mostly
So,
uh, you won't see it. I mean, the best example you can think about it, like you have a large volume of logs, right? You
system
want to
backend
write it.
logs, application logs. Mm.
Yeah, you want to write all those things, but the read happens like once in like maybe like log, how many times you look. Whenever you
Yes.
have problem, I look for that
Mm.
particular day.
Yeah.
So this uh, this is the pattern they followed. Like it just keep the caching service. You directly go to the parent for the write. Whenever the read comes, it go through the your layer.
Mm.
So these are all the patterns,
Yeah.
right? Now you understand this pattern, like usual design system questions like, okay, I mean, what Praveen mentioned, right? He mentioned like you have a star count, which caching techniques you are going to,
Mm.
like which caching pattern you are going to use it.
Yeah.
And they may get into even which algorithm, eviction algorithm you are going to do. Like the pattern usually sit bit higher than the the underlying algorithm, right? The
Mm.
eviction policy could be different for, I mean, any of the eviction policy can be implemented in any of this pattern,
Yes.
right?
Yes. Exactly.
So usually they start with which pattern you will use it. Like
Mm.
mostly, uh, yeah, we already answered that question, but yeah,
Mm.
it could be write back cache, right?
Yeah.
So in in uh, mm, yeah. So whenever you design a system, if you are not, most of the time you are going to interact with the first side cache policy, and you will be managing uh, configuring the Redis and saying that this
Mm,
is my eviction policy, and you will be uh, doing it unless until your organization has some specific guidance to use some managed solution. So some of them may be like very heavy customer of AWS, they may be using DAX in front of it. But most
mm,
of the like smaller startup or like not smaller, like larger startup also, most of the time they use side cache.
okay. Probably they
So
also yeah experiment a
Mhm,
lot, like what policy should be done and how to manage things, and they want some flexibility on how they manage stuff like that.
mhm,
Yeah.
correct. Yeah. Yeah, that is pretty much, I think, are we on time, Praveen? Or we are
Yeah, I
out of
think,
time?
oh yeah, we are almost 40 minutes into the call. But I think we
Hmm.
covered, I think, starting from what is the measurement unit for caching, hit rate, and time to live is also very important. Then we talked about the algorithms, different algorithms,
Hmm.
and the what are the eviction policies. And then we saw
Hmm.
as a whole system how caching can be placed and in which use cases what type of caching should be preferred. So this is only with
Hmm.
respect to caching. As Shibin already mentioned, as we go deeper into these sessions, we will see in the overall picture where this, for what kind of problems, which strategies work better, right, Shibin?
Hmm.
So I think today we are good. We covered a lot of ground today, and it's a really good
Hmm.
starting place for our audience to get more into
Hmm.
caching. And Shibin, I think we
Hmm.
can just close. Maybe you want, if you want to say what's coming next, and then yeah.
Next week we'll see a an enterprise grade solution, maybe like using the Redis,
Mhm.
because that's the most used thing.
Yeah. Okay.
Uh, then we can look into something. At the end, we can have like a caching design.
Yeah.
Maybe if we get a time, we can include in as part of the next session itself, like designing a larger system, maybe like take Instagram itself and design it,
Mm.
or something else, or a smaller scale. Uh, if we
Yeah.
get time, we can learn next session itself or like next to next session. Yeah.
Yeah. Yeah. We can go. I think we covered a lot of stuff today. Very interesting. So, thank you, Shibin. Thank you for sharing your insights and having a great discussion. And I think our audience also have a lot of takeaways today. And please, guys, like if any of you wants to know something more specific, some more examples, or any suggestions you have, please put it in the comments. And I think we will also link the some documents which we discussed today in the comments. So till next week, then next session, Shibin, then have a nice
Yeah.
week and see
But
you. Bye.